Let me start the talk. Today I'm going to present Quadtree and its implementation on maps using D3. Before getting into the talk, there's a small game. Let's play this. This is a small bit of a map of London, and I've searched for Coast of Coffee, and I've found various outlets. But can you figure out like how many are there? Basically, like there are few spread across. You can just guess a number. Maybe in this chat window. Let's see who gets closer to the actual. Sorry. Oh, I think the chat window is not visible. Okay, 15, pretty close. 17, 20. Did someone watch the? Did I open the slide with the actual answer? I don't know. This is the first time I'm
No,
getting.
you didn't. You're safe. We just see
Okay.
map markers.
Okay, that's cool. Let's get on with the talk. My name is Guna Narayanan, and I go by the name Guna. And I'm a front-end developer in JFrog. I've been part of JFrog for the past 3 years. I've been developing a lot of UI things with JFrog, and Maps is part of it. And this is my social media ID, Nirmal93 Guna. Before getting into the talk, one more thing. I hear that people will want my slides post the talk. So yeah, you can go to this site where you will be able to access my slide deck, and you can rate my talk, and you can even sign up to receive a free version of the Artifactory and JFrog platform. And look out for the QR code. You can directly scan it if you want. Let me give you a few seconds where if you want, you can take a screenshot if you want to look at it later. The link or the QR code.
Rest assured, our facilitators and friends here are screenshotting this like crazy, and we're going to share the link.
Sure. And Arya, share the link as well on the chat window if you want to directly access it. Please do that. Yeah, so then let's get on with the talk. So these are the things that we are going to look today. What is clustering? Basically, I'll tell you why clustering is done and what are the uses of clustering, and then we'll get on with Quadtree. You might have studied it in your college or in your school. I'll explain you the fundamentals of Quadtree. What is it, and where is it useful, and uh, how is it helpful in clustering, and then we'll get on with how we are going to implement it on map. All this will explain how I have done and why I have done it, and the next thing I'll show the demo of our application where I have done it, and finally I'll tell you why I didn't do any map libraries. There are a lot of map libraries available and a lot of good ones in that, and why not use any library? And they almost everyone provides um, Quadtree or a clustering mechanism API in that, and you can easily use that, but there are cons as well, so let's discuss that as well, right? So clustering of markers. So the right answer was 17. So some of the markers were, on top of each other, but many people got it right. I mean, if it was one, I would have given a shout out, but a lot of people got it right. So I think maybe I should search for something else, or give me a suggestion on next time what is very popular in Canada, maybe Toronto. Maybe I'll do that. I'll update the map. It's time to update, I guess. So let's see why clustering is very important. Why it will be useful. So first thing is visual help. You don't want the user or your customer to see thousands of markers in a particular location when they search for something, right? It will obviously hide the map basically. Obviously zoom will help, but still zoom is not the solution for this. But with clustering you can group them together and show them, okay, there are some markers here. If you want, you can zoom and see. That way the map is not hidden, and it will provide visual help that way. And the next one is heat maps. So you would have seen in weather forecasting how based on the attention each place is getting, whether it is a tornado or a whatever it is, clouds, the clouds density and all that, how based on the attention each position is getting, that will be marked with a different color. So this concept you can achieve using Quadtree as well in clustering. So based on the attention each position is getting, you can give a particular color for that. So that is one thing. And last but not the least, the performance improvement. Obviously, each marker on a map you see is a element, HTML element or SVG element. So instead of showing one marker with a number saying 10 markers are there, if you show 10 markers, that will obviously take up the browser memory. So when you use clustering, obviously the performance of your page will improve. So when I explain clustering, what makes more sense with clustering is zoom. So simply if you want to show markers across position, I mean saying there are 10 markers here, that wouldn't make sense. So basically if you add a zoom to it, when you zoom in, the marker should be go to their respective place. Suppose if there are two markers grouped together, and when you zoom in, and they should again go back to respective place if they are not close by. So that's how we have to implement clustering. That's very important. And yeah, any questions on clustering?
So just to help recap, the idea is like gathering near points together and then like putting them up into like kind of like a super node maybe in the HTML or like in the conceptual data structure, and then that you can kind of like break into pieces, right? When you do zooming or like other activities. So exactly. Does that sound right, Guna?
Yeah. Given the right context. So yeah, exactly that. And adding to that, the concept of zoom, exactly. So when you zoom in, it should go to the respective place based on how you are considering it should be grouped together. The same way you should understand when it should not be grouped together as well. So that's one thing. So moving on to Quadtree, let's see what Quadtree is and how we are going to use it here. So Quadtree is nothing but a tree data structure algorithm. So a tree data structure algorithm is nothing but a parent node will be divided into multiple children nodes. So it might be how many ever children nodes. Since as the name suggests it's a Quadtree, so each parent node will be divided into 4 children nodes. So consider a square where there are 4 sides and each side is equal. So when you split it into 4, again it becomes a square, right? So each child quadrant will become one node, a children node. So again that can be split into 4. In that way you will not lose any space. See, if you take a square and group them together, you can't cover every space, right, without overlapping each other. So if it is a square, you can place one square, consider the square as a plane, and you're splitting it into 4. Again that becomes a square, and again you can split that into 4. In that way all the areas will be covered. Okay, it will be like a top down approach from one parent, multiple, I mean 4 children, and inside that children there will be another 4 children, will go on like that. So you can split up, manage and access each point in a plane easily. Okay, let me get into more detail on this. So see this image. If you see here, there are multiple objects or points placed on a plane. So if you see, there is a big plane. This is the parent plane. Inside that, that's split into 4 children quadrants. And here, if you see each point, when you keep it, if the points are more than 4, it will again get split into another 4. So in that way, each point you will know which quadrant it is exactly placed in. It will go on like this. Okay. So once this quadrant is split into 4 smaller quadrants, the points will be grouped closely together, and each quadrant can be grouped together. Suppose if you group this quadrant together, these 2 points will be one marker, and these 2 points will be one marker. This is how Quadtree concept works uh, on a map. And how we are going to group them is, if you are on a consider, let's say you have 6 level of zoom. Okay, 6x, let's say you have 6x, and when you are in 1x, let's consider this is 1x, the whole parent is 1x, and what will happen is it will be split into 4, and whichever point is lying on this first quadrant will be grouped together, second will be grouped together, and so on. So you will have only 4 markers, and when you zoom in to second level, what happens is it will be split into another 4. Each quadrant will be split into another 4. Consider this one, it will be split into 4, and this will become 4 quadrants, right? So this 4 will be 4 different markers. In this way, as soon as you zoom in for each level, each quadrant will be split, and you will get it will go to its own position. If it is alone, it will go to its own position. If it is together with another point, it will be grouped together. So let me, I have a quote pen that I created that will, show the, sorry, I see a message. Yeah, perfectly clean split. Yeah, 4, the concept of Quadtree is actually 4. So if you split, if you keep one point, it will occupy one space, right? If you put 4 points, it will be equally split. If you go to 5, then the 5th point will be part of another quadrant. Let me show you here. It might be a little confusing, but let me show you with an example. So I'll place some objects on the left side, and the right side will show how the nodes of a quadtree will be created. So consider this as a plane square, and I'm going to place it on the first point. So a parent node is created, and then I'm going to place it on the second point. So the parent is split into 2 now, and the third point, and finally the fourth point. So if you see here, sorry for that, it's not accurately placed. My bad.
Could you walk me through that again?
Sorry?
Could you walk me through that again? Because you mentioned something about like the points being accurately placed.
Okay, so so if you see here, I've placed the points accurately on 4 different planes. Consider this as a whole square, and I'm splitting it into 4. Okay, each quadrant I'm keeping 1 point. So the parent node is split into exactly 4 points. Okay, and let's see, let's consider the first quadrant. Imagine this is the first quadrant. I'm going to split, keep more points here. Then you'll see this quadrant is split into another 4 point now. If you see, when I hover over it, you can see the highlighted point there. So it goes on like this. Again, if you want to split it, you can keep. It goes on like this. So each point, when you keep it, it will the plane will be split into 4. Okay, so consider this as an XY plane. Okay, so if you keep a point, this will have an XY value. It will be like X position and Y position will be there, right? Suppose it starts from 0, 0, it goes on like this, say 4, 4 or something. So this is a plane, and each time when you keep a point, this will have a value. That's how we define, that's how you find out where a point is exactly on a plane. So here what it does is, based on the squares that imaginary squares that I showed you here, when you keep a point, the points will be split. I mean, the quadrant will be split into another 4 quadrant. And consider this for each quadrant as a node, like how you see here. Okay, so the first quadrant is split into another 4, and the first quadrant of this one is again split into another 3, and this one is split into another 2. It goes on like this. Do you have any questions? Or is it difficult to follow?
Just to recap, basically, when we're zooming in, we're unsplitting the leaves of a node. And when we're zooming out, we're basically going from the bottom to create, hiding the leaves and keeping track of how many children there was of that node.
Exactly.
Right.
Exactly. Yeah. So basically, let me share the code pen. Yeah, so basically consider this right hand side where you see the tree structure and you see multiple levels, right? The first one, second one, third one, right? So consider this as the 1x zoom. Okay, you're in 1x zoom, so you'll see only 4 markers because there are only 4 nodes.
And each
right?
node would be representing one quadrant of.
Exactly. Exactly.
Yeah, that totally makes sense.
Yeah. So all these points lying under this quadrant will be grouped together. This quadrant is nothing but this area. Okay, all these points that you see here will be grouped into one marker. This is at 1x zoom level. But when you go to 2x zoom level on this particular quadrant, suppose I'm zooming on this particular quadrant, what happens is it is again split into 4. So you'll see 4 more markers here. The one marker is split into 4 more markers. 3 are single markers. The one is again grouped together. So this is at 2x. Now, when you go to 3x, again, you will see 3 more markers. That's how you traverse and go. So when you go out, I mean, from 4x to 1x, all the markers will go on and get grouped together.
Yeah, it's helping me to when I see it from a Z perspective and zooming in and out from that, it totally makes sense. It makes it really easy.
So what determines the parent node here? Like what kind of factors determine the parent node?
So it's basically the concept is the quadtree is nothing but, one square will be split into 4, right? So the whole plane, see this whole plane will be a parent node. And when you split it, again, it will be split into equal 4 nodes. If you see this image here, the whole parent node is the whole plane, and when you split it into 4, then this one becomes the next parent node. The first quadrant, each quadrant becomes next parent node, and that when it gets split, the next quadrant becomes one parent node. It goes on like this. So every space will be occupied. None of the space will be left out because it's a square. And you're going to, cut down into each square quadrant, and again it becomes a parent node. It goes on like this. So as much as how much ever you want to zoom, that much squares you can make. I mean, quadrants you can make.
I had a question about the splitting. So are you saying that for any given bounding box, let's say this square, it's always going to be split through the center, or is it based on the coordinates of your existing points? So if you start off with a cluster of 4 points in the upper left-hand corner, will the origin or the split happen in the center of those points, or is it always according to the bounding box? Yeah.
So whenever you keep, whenever you keep 4 points, only 4 nodes will be created. Only the 5th point will create the, it will determine whichever is the parent node. When you're keeping this 4 points, it's just saying, okay, there are only 4 points. When I keep the 5th point, it will split the quadrants will be split. Okay, and I'm going to keep the 5th point. Let's first try with this place itself. So what happens is this is considered with one of the maybe I'm guessing it's considering with this point, the first and this point. or together. Yeah, right. So when I hover, it's showing there. So all these three are coming under the outside planes. So the same way, let me again try another one. Let's keep a point on the opposite end. Let's see what happens here. So this point is becoming separate because it's splitting in the middle. So whichever point you keep the last point, I mean, whichever point is the edge, it calculates the edge place of that point. And from that, it's splitting. So here it's considering till here. So it's splitting somewhere around here. Is it clearing your doubt?
I think so, yeah. So when you first made the cluster of 4 points, it I mean, I guess it's grouped together and then partitioned through the center of those. No, I'm not sure. Maybe I'll clarify later.
Okay,
So if you
sure.
put a lot of them on first quadrant, I was just testing out the code pen. It
Yeah.
breaks the tree more and more and more and more the more I add. If you just add a lot of them close by, it's gonna break out, right? So if it's based on the screen view of quadrant, how's that being calculated for that specific point? Is it breaking down the quadrant into smaller quadrant?
Yes. So basically, I'm not sure whether I understood your question. So what happens when I put a lot of points here is like you said, each quadrant will be split. If there are more than 4 points in a particular space, that
Mhm.
place will be split into 4 quadrants.
Got it. So basically we have this quadrant and then we have another quadrant inside of the first quadrant,
Exactly.
the small one.
Exactly.
And if we put
Exactly.
more than 4 in first quadrant of the first quadrant, it becomes another quadrant.
Exactly. That will be again split.
Got it.
So when it becomes more than 4 points, that plane will be split into another 4.
Got it. Got it. So
Okay, so
basically it keeps on getting smaller and smaller.
Yeah.
And we're going to control the leaf and tree parent and child relationship based on zoom.
Yeah.
Got it.
okay, yeah, I think I understand. It's yeah, based on number of points in the
Yeah.
right in the quadrant. If so, for example, if you start at 4 in the upper left-hand corner, it's still treated as one parent, but the moment you add a 5th, it detects this and then partitions that space into 4 quadrants, and then
Yeah.
so on and so forth. Okay, makes sense.
So there's a question on the chat. So do we recalculate the whole tree every time we zoom? No, we don't need to recalculate the tree every time we zoom, because when you load the your page for the first time, you will know all the data points that you have that you are going to plot, and that time you can create a data structure, Quadtree data structure, and that will have all the information where your points are. So you don't need to calculate every time. It will if we are calculating, then it will become heavy. What it will do is it will calculate and create a data structure, and it will be easier for you to traverse through that using Quadtree. So that's the benefit of using Quadtree. Traversing through a tree is little bit easy compared to searching for a point in XY plane and all that. So it will not make sense if you are going to create a tree every time. I hope that answers.
So if I'm understanding correctly, what will happen is like every single time if a parent node has 5 other child node hidden inside of it, when you zoom, all that happens is it says the program tells the parent node unhide the children, and that's going to be basically
Exactly.
if it's going to be max of 4 traversal for loop it'll run 4 times at the max.
I mean, not
Instead.
everything, right? It's
Yeah,
going
not
if when
everything,
you're
just
zooming
that
in. Exactly.
that parent.
Yeah.
Got it.
So it will not go till the end. No, it will go only one way, and that's going to again split into 4. I mean, how many other points are there? Basically, guessing if there are a lot of markers, it will be split into 4. So every time you go, it will be one level, and it will have 4. And when you zoom in, it will go and it will have only 4.
Yeah, that's clear.
Awesome. I'm getting mind blown. And I see parallels between this and like the kind of recursive patterns and generating components in abstract syntax trees. Anyhow, I'm gonna let you continue.
It is amazing when you see from a map's perspective the whole data structure.
So there's one more question. Would the Quadtree data structure be recreated every time a new point is added? So whenever you're going to add a new point, I mean, let's see, we are going to add a node, or basically in our requirement, we don't, dynamically add a point. So I didn't consider this, but this is a, a good question. Basically, if you are going to dynamically add points, depends on how we are loading the SVG though, how we are going to add the marker. But again, I think it will recalculate, and it might become heavy if you're going to do that. I'm not sure. I haven't tried this, but this is a good thing to consider. I don't
One
have an
can
answer
just
for you,
find
but
the correct parent node to add the child in that
Mhm.
case. So when you're adding a new one, it'll just traverse the parents and find which parent the child goes under.
Well, I mean, I thought when you're a particular level of zoom, that means you're associated with a particular level parent, right? And that
Yeah.
defines sort of your, yeah. And then if you dynamically added a point, I think unless in the most trivial of cases, you probably would have to reconstruct the tree from that parent downward. Everything above obviously won't be affected because everything above is outside of your bounding box.
But wouldn't the data still, the data would be still there, and SVG is being generated just from the data that were supposed to be in the bounding box, but the data at the back end would still be whole, I'm guessing.
Well, if not, if you store the tree locally, I guess. I don't know. Yeah.
Yeah, that makes me wonder, where is this stored? Like
I've worked with Mapbox. Basically, you usually get all the data first, and then you manipulate the viewport you have. Basically, do you want to show these nodes right now and hide everything else? Because the most expensive calculation happens on the UI, but the data stays as it is. And when you're adding a node, you're not adding an SVG, you're adding data point. And that data point, is it gonna be shown or not, is based on the zoom and the viewport box, right?
I'm assuming that and correct me if I'm wrong, Guna, but I'm assuming when you first load it up, you're given you have a number of points, you establish the bounding box for all those points, and then that establishes the sort of level of zoom you're at, and then from there you can just construct the tree, the entire tree, right there and then. And so it's front loaded all the way, and then later it's when you're traversing it's easy. Is that sort of how it works?
Yeah, basically. So you first get the data and you create a tree structure, quadtree structure with that data, and then it takes as he said, the viewport determines what all markers you will be seeing based on the zoom and all that, and but the structure remains the same. The structure, whatever is created, remains the same. But the viewport, the zoom level and all decides what all markers and which level of zoom we are in and which quadrant will be zoomed to. But yeah, the structure remains same.
Joel, are you saying based on zoom you fetch data?
No, I'm saying that.
No.
I'm
Because
saying
that's
that
still really expensive.
no, you start with the initial set of points, and then you construct the entire tree for just that set of points. And then, traversal is easy. And adding points and doing all that manipulation, I think, is obviously, Guna would know better. You'd have to do some sort of optimization for that.
It depends whether you're leveraging an existing API. Like I would very lazily reach for Google Maps.
No, free stuff, leaflet.
Yeah, that too, the gateway. Yeah, leaflet, the library, for those of us who are scraping the surface of this this area more. It is a great tool for visualizing maps.
Yeah. So yeah, they have an active team monitoring it and adding new features. So yeah, if I'll get to that con spot in almost the last slide. If you feel like that's okay, you can go ahead. That's what I mean. I did the analysis before thinking, okay, I have to do mine. So I see a question on chat. I really have no idea. Can someone help me with that?
Could you expand on this question a little bit more? Like, what do you mean by OSM URI segments?
Okay, so hi, Gregory here. We work with maps every day, and we're working with real-time data, and we're updating the position of our fleet trucks that we have on the road every second. And at the end, I'm happy to share a screenshot if you want to take a look at it. But I run an instance of something called OpenStreetMaps, which is a free and open source.
It is based on leaflet.
It is. Well, it's the back end, right? So
Yeah.
it's So I actually run like the GIS database and everything else, like all of the underlying stuff, so that we don't have to rely on Google Maps for our mapping. Plus we have some customizations. What I'm asking is, I'm looking at the URI segment. So basically what separates the slashes, and I'm seeing some numbers here, like 15/5721/whatever.png. I have a feeling that, maybe I'm missing something, but I have a feeling that these numbers are, this is what's automatically generated by Leaflet, are what's used in order to define the Quadtree that it needs to actually pull the tiles. So when the database is queried, these numbers are somehow translated into zooming in, as you've been saying. Am I way off base here, or? I'm just trying to figure out what the numbers mean.
Put a pin in that idea, and not because it's not a great question, and I only have partially the context from working in a different company that use something related to that as a library.
Okay.
I just kind of want to gonna continue
for sure. Yeah, sorry.
Revisit this idea at the end. Yeah, sorry about that, but this is actually one of the most interesting and intellectually ticklish talks we've had in a while at JS Tech Talk, and I'm super happy that people are coming forward with questions. This is exactly what we want. But I also want to be respectful of Guna's time, and he's in a time zone where it's very early in his day. We agreed on a certain amount of time to give the talk, so I want to let him kind of get through that before we circle back to this. But yeah, definitely want to address this after. Yeah.
Sure. Would like to be part of the Slack thread as well. So let me continue my talk where I'll explain how I've implemented the clustering on maps. So basically, I didn't implement the Quadtree algorithm all by myself, because D3 already provides one. So you just have to inject your data and it will create a structure for you. And using the API, you can derive at the markers, or how they're going to be grouped together. So this is how I did basically. So you have your point. Sorry. Okay, so you have a set of points that you want to plot on a plane, SVG plane, and what you're going to do is pass them through the D3's Quadtree API, and what it will give you back is a set of a tree structure, basically an array, with a tree structure, one parent and 4 children nodes. And using that, you're going to traverse through each grid. So like I said, when you're zooming in, a particular quadrant will be zoomed in, and for that grid, it will go through the structure, and it will find out if any point is lying on that particular grid. And if there are more than one point on a particular quadrant, it can be grouped together. If not, it can be directly put at the place where it is needed. So that is this is the D3's Quadtree API. So you are just passing the data point, and the cluster range is defined by you. Basically, based on your zoom level, you have to calculate the side of the square. So how big your square needs to be. The bigger the square, the more the grouping will be. The smaller the square, the less the grouping will be. Because if the square is big, then there will be a lot of things grouped together, and vice versa. So this thing you can decide based on the requirement, basically. So if you're having a big window where you're showcasing your map, then probably you can have a smaller cluster range, so that small squares will be formed, and only when it is required it will group together. But if you're having a small window where you need to show a map, then you can probably have a bigger cluster, because if you want, you can zoom in and you can see you can see the markers going to their respective place. So cluster range is manually, you can decide based on your requirement. And all these edges will be calculated by itself. I mean, this function automatically calculates it. So for each, when it travels through each grid on the plane, what is visible, it will find out, the Quadtree.visit will find out if the node is present on that particular grid. Okay, so if there are, when it comes here, and if there are more than one node falling on the same grid, then you can calculate a center point. So basically, when you're grouping markers together, you can't keep at one point and say all the points are available at that grouped position, right? What you have to do is consider the edges and find the midpoint of the edge and place the point there, so that when you zoom in, it will be split and it will go to their respective place, obviously, but it will look good, because you can't have two different points when you're grouping and put it on a different place totally. You have to put it on the center of the point. That's very important when you are clustering markers together. Sorry, I'm not following up on the chat.
Yeah, don't worry. People are just commenting on things that were said before. Something I'm wondering about is what's involved in calculating the center point? Is this a kind of a existing method that's part of a library, or is this something that can be configured by like the developer using it?
Okay. So basically, all this, what I'm saying is already available in many of the libraries. Even they've implemented even better. But the point is how much you want to use them, and basically it's kind of even if requirement is not there, you can just try out your way, how you want to do. A lot of customizations you can do on this, and what I have done is a basic Quadtree implementation, all the basic stuff, how the libraries would have implemented. But if you want slight change, like, I don't want to place it on the midpoint of a box, I want to place on some other space and all that, if you have control over it, you can definitely try it. So I think any questions on the implementation?
I'm going to ask a question that's very basic. What do you mean by edge?
Okay, so it's just a variable where, edge is nothing but a side of a square. So why? Yeah.
Sorry, go ahead.
Please go ahead. Please go ahead.
So from my understanding, edge X and edge Y is basically trying to calculate the distance between points. Is that what they're doing?
No, basically, let me go back to square. So let's see, this as one quadrant, right? So if you are in zoom level 1, I mean 1x, then this will be one grid. Okay, so edge x is nothing but, I mean, let's get to the code. So edge x is nothing but it starts from 0, and every time there will be a one cluster range being added. So basically this will be edge x, and when one loop completes, this will be edge x. So this will be a starting point. Okay, so
Oh, I see. I think I understand. But go ahead.
Okay.
It just clicked. So is it going
Okay.
from point to point and trying to see, okay, this is the width of the box and this is the height of the box, and then
Height,
I'm going
exactly.
X, and then
Yeah, so it has to go
next
through
box of the X, and then
exactly.
going through all the Y's and going. So basically it's like a table of boxes. Then you go to
Exactly.
row, column by column,
Yeah.
from
Yeah.
top to bottom, checking out each boxes.
Yes.
Yeah.
So basically, at first level, it will go through only 4 boxes. This is the advantage of Quadtree. If you consider any other, I mean, I don't know any other methods, but if you see normally, if you know XY plane, if you want to search, you will go through each point, right? 0, 1, 0, 2, like that. Here, every plane it will go through only 4 way. If it is not available on that 4 ones, I mean, any one only it will be available, right? Every point will be available on the first 4 quadrants. And inside that, it will go through the next 4 quadrants. So this is how it searches. So the search becomes easier. I mean, it's not taking a lot of time. That's why searching through Quadtree is way simpler, because you can easily find which quadrant it is available and directly go to that and directly find the next quadrant. It goes very fast. That's why
So
searching is very fast. Yeah.
cluster range, like edge X plus equals cluster range, would be something like width divided by 2 or something, like width of the viewport divided by 2, then you divide that box by 2. Is that how it goes?
No, it's not divided by 2, right? Because whatever you give as the cluster range, that will be one side of the square. So when you go to the next square, you just add that cluster and it becomes the next square.
So you're determining a piece of box beforehand. Say we're gonna say we're gonna go by every 10 pixel. We'll consider every 10 or every 50 pixel as width of a box, and every 50 pixel as the height of the box. So what we'll do is, in this 50 pixel, how many 50 pixels of heights we have, go through them. Then we'll go to the second 50 pixels. Then we'll go through the height for all of them. Is that how it's going?
Yeah, exactly. So if you see here, it's a for loop inside a for loop, right? So first for this, when the edge value is 0, it will go through the first one. So this, it will start from this one. The first square will be considered. Then the y value will increase. Okay, so when the y value increases, it will go to the next box. It will go to the next box and it will finish this one. Then the x value again increases, it will go here. And the y value will be here. This box will be considered. Then this one. Okay, for each x value, the corresponding y will be. So it will top down approach. It's going basically, but that you can modify however you want. If you want to keep y value first, and if you want to go left to right, that also you can do. You have control over it. You just have to change the for loops based however you want.
Yeah,
That's it. You just
breaking
have to
down
pass
like a
the
table made it really easy to understand. Like making the whole viewport like a table.
Yeah, exactly. Right. So this is how you traverse through the grids and calculate if a point is. I mean, the Quadtree.visit API will automatically give you if it is available on a particular grid, and based on the number of markers falling on a grid, you can just group them together. Right. So you already have the edge values. So based on that, you can calculate the midpoint of each grid, and you can place the marker. So that will be the where you place the grouped marker if there are more than one points in a particular grid. Okay. So so let me move on to the demo. So this is a JFrog platform. JFrog offers a DevOps platform, end-to-end DevOps platform for to ease out development and release of the products. So here is the map view, which is called topology, where we show something called a deployment. So deployment is nothing but another server, which is basically artifact tree. What we do is we connect them to each other. So there will be like mutual connections between deployments. So here, if you see, deployment is nothing but a server, as I said. So there are two servers that I have added here. The home one, which is the current one, is in the home one is in Toronto. The other one I have added it in Detroit. So if you see here, these are close to each other, right? Might be separated by a few hundred kilometers, I guess. So if you want to, if you're not grouping them, what happens is it's going to be on top of each other, and it'll look ugly, obviously. So let me move the selection here, and it's going to look ugly, obviously. So what I've once the implementation is added. Clustering, what happens is when you zoom in, as much as you zoom in, since it's very close to each other, still it's grid, it's falling on the same grid. But when you zoom in more, it obviously falls on different grids. So when it falls on different grids, it will be moved out of grouping and it will be put on their respective place. So again, when you zoom out, it will again fall on the same grid, because the cluster range will increase, and it will come under the same grid and it will fall on the same place. So this is how we have implemented. This is a very minor requirement for us. We just had to implement, a map and show some points wherever you want, and few SVG additions to that. That's it. So basically, clustering was very important for us, because there will be a lot of lines that will be, connections between deployments, and lot of them grouped together probably. So that's why the requirement came into picture. So any questions on the demo part?
We'll take silence as a no. Tara, did you have something to say? And I'm sure there's going to be ideas brewing at the end. I know I put a pin in an idea earlier that we're going to recover. So yeah, hold your horses.
Yeah, like maybe not so much of a question, but like just to help other people. But can you talk a bit more exactly how the zoom level gets like translated into the range, right? When do you like conceptually on the data structure, like you have the whole topology of the single supernode, and then like there's like a point where you kind of transition, like, okay, I zoomed enough that I decided to kind of like let's go to the next level kind of thing, right? So maybe you can talk about that, because like graphically it makes sense, but for some people it might not kind of like connect with their head, like, okay, how do I turn this into like numerics? Because that's in the end, that's like what that's what we want.
Got it. So yeah, let me go back. Yeah. So if you see here, the first thing what you do is create a quadtree structure using the data binds that you already have. So you already have a tree structure similar to what we have here, but we don't have any grids or clusters, anything defined. So every time when a zoom happens, what you're going to do is you have to calculate a cluster range based on the zoom level. So every time when you zoom in or zoom out, you can emit an event saying, this is the zoom level. It is in 1x or 2x or 3x, whatever it is. So for me, what I've implemented is 1 to 8. So I have implemented till 8x. This is the maximum zoom I can do. So it's 8x, from 1x to 8x. So every time the zoom happens, this will create this will emit an event, and with that, value, the level of zoom on this plane, I'll calculate the cluster range. That is dependent totally on you. You can manually, enter, say, every time I zoom in, I mean, I should have say 5 into the zoom level. This should be the cluster range, or it should be the opposite basically. So it should not be 5 into, because when you zoom in, the cluster range should become smaller and smaller. So, you know, divided by basically. So you can you know, it's like a trial and error method. You can try which one works better for you, and I'll show you one disadvantage as well using this. Then I'll explain you why that happens. I don't have a better solution for that. We can, you know, discuss about it. Maybe some other method is there. Yeah. So cluster range is totally calculated by you. So every time when a zoom happens and you calculate the cluster range, and again go through the loop and find out uh, which all markers will fall on which all quadrants, and you can again calculate it. It sounds heavy every time you're calculating, but I mean, it's worth it.
So
That's what I feel.
is it like
Yeah.
you start with a certain grid? Say it can be it can be 9 by 9 grid. You're saying that we have 9 grids on the view, and when we zoom in, we have less grids. Then we zoom in more, we have lesser grids. Is that how the calculations happen?
No, not like that. So suppose you know the plane, right? So this is the SVG. So it starts from 0, and it maybe ends with 10, 10. So if this is the plane, and every time, you know, if I've zoomed in and zoomed out, this whole plane will be considered as one parent grid. Okay, and I mean I mean, not a parent grid, but one plane. Okay, so based on your cluster range, it will be divided into multiple boxes. So what happens is when I give you know, 0, 1, so it will be split into 10 things, right? It will be 10 columns and 10 rows, so it will become 10 into 10, 100 boxes. Okay, and based on that, whichever markers are falling on under that box, it will you know, group them together. And when I zoom in, particularly, suppose I've zoomed in 4x, what happens? Or you know, I've zoomed in 4x, let's say 4x. What happens is again you have to give a number. So again, what happens is you can even keep the same cluster range, because this whole plane is the same. Only thing you're zoomed in, but the whole plane is the same. So you can again keep 10 into 10 boxes, 100 boxes, and whichever falls under those 100 boxes, that will be grouped together. The difference is whichever you have already grouped together might fall under different boxes. So that will not be grouped together anymore.
So under the hood, the data is same, and you're saying if this part of data is part of this group, show it.
Yeah, group them together. I mean, not show it, group them together. If it doesn't fall on the, I mean, 2 markers doesn't fall on the same grid, then you know, show it separately. Suppose here, if you see here, there might be, say, 10 boxes. Okay, so there are 10 boxes, and this particular 2 points fall in the same box. So I'm grouping together. So when I zoom in more, I mean, the next level of zoom, these go to different boxes. Because you have zoomed in, the size might be same. It is totally dependent on how we are going to calculate the cluster range. It might be same, or it might change on zoom. It doesn't matter, because the plane is the same. You don't have to even change it. But when you zoom in, obviously the points will separate out, because they are in totally different places.
Basically,
So
the whole map is coming closer, and the data split is getting bigger.
Exactly.
And the grid system stays the same. And the one that I was saying, that's much more expensive on the viewport. I was thinking of like expanding the whole viewport grids, which is much more expensive. But if the viewport grid stays the same, and we know the ghost data points, we basically know when to split them and when to.
Exactly. So the viewport remains the same. The cluster range, you can decide basically. So if you want to leave it the same, you can do it. But if you think, okay, when I'm zooming in, I want them to move apart faster, then you can provide a smaller cluster range. You can reduce it based on zoom level. It's totally dependent on you.
Yeah, now I understand. Now I understand. Yeah, it's very clear. Yeah, sorry, I ate up a lot of time.
you also help summarize and confirm a lot of the ideas. So yeah, like this is definitely a more dialogue kind of tech talk. We have a
Exactly.
very
Good.
modest
Thanks, Jen.
like Canadian viewership. Usually people stay silent for like the whole 20 to 45 minutes. So I think like given the topic, this is really good for clarifying, you know, the intended results and stuff. I think most people here either worked with maps once or 5 or 30 times, like we have a range here. So I appreciate, at least by the end of the talk, we get some final, you know, answers and insights on it. I like finality, you know, not to go on Stack Overflow and like Google like 10 more things. So yeah, thank you for asking those questions.
Now I feel good. Thanks, Jen.
So I see one more question. This is actually a valid question, to be frank, not a stupid question, because see, this was the disadvantage I was talking about. I mean, I said I would talk about. So what if the zoom didn't happen and you move, suppose like I move it here. Okay, what if they again, you know, fall in different boxes? Again, it will be split. So there is a catch here when I said, you know, there is a disadvantage of using Quadtree. So let me go to this, you know, image again. Here, if you see, there are a lot of markers in this position, right? So consider this marker which I'm pointing to and the one next to it. Okay, there are 2 markers very close by. They are really close by. I mean, if you have a text label like I have on mine, you know, if you have a text label something like this will obviously fall on top of each other. But when you've zoomed in to this level where these 4 quadrants are shown, obviously these 2 are not falling on the same grid. So what happens is this won't be grouped together. Okay, this won't be grouped together and the text will overlap each other. So this is a disadvantage which you can reduce as much as possible using the cluster range. How you define the cluster range? Suppose if you're increasing the cluster range, then this will probably you know, lie together. But
In that
this
case, you'll affect the effectivity of the performance, right? Quite a lot.
I mean, sorry.
Won't it affect the performance quite a lot if you make the cluster range too small? The boxes.
I mean, if you are making it small, obviously there will be more markers, but again, like I said, it will overlap because if the cluster range is small, you will not see a lot of groups happening, right? Because the cluster range will be small, and you know, even nearby markers will fall in different grids, and it might not, it might overlap. So increasing the cluster range will obviously improve the performance because you are grouping a lot of markers together. But yeah, with that way you can avoid, but it's purely based on requirement. You can't define every requirement same, right? Basically you might have a different requirement, so you can adjust based on your requirement. And if you think this overlap issue is not happening a lot, then you can, you know, reduce the cluster range and, you know, create more grids so that there won't be a lot of groupings happening. So that's the disadvantage I was talking about. So yes, it's a issue. So because it's a square, so grids, you know, in a square, there will be 2 points that might fall close to each other and it might again overlap. So I hope that answers the question. So yeah, the last and final topic: why not use map APIs and libraries? So when I was assigned the task of, you know, creating a map and, you know, displaying the markers and all that. So I mean clustering basically. I considered all these libraries because I didn't at that time didn't want to spend time on, you know, already existing concept and create my own you know. Clustering API for my requirement and do everything from scratch because everything is readily available. Basically, libraries are maintained by, you know, a lot of contributors. Most of them are open source, and I wanted to go ahead with that. But there are a lot of issues I had to face because our requirement, as you saw, is very simple. Like it's just a zoom, a normal map with a projection, and just gray and white, and nothing else. No other implementation is there. So all these libraries came up with a lot of you know, heaviness on top of it. There were a lot of dependencies they used, and customization was not easy. Whatever they provided, I had to use, and whatever APIs that are available that I need to use, and you can't do what you exactly want. The requirement might be totally different. What I have here, like when you hover over, it shows this and this design, everything. It's SVG, right? Again, so everything was so much customized. So I was not able to use any existing libraries and integration with other visualization. Yeah.
I wanted to ask this question. So the map itself is static, from what I'm understanding, right?
Yeah, it's a static map.
And how are you attenuating the values on the map? Is it like, so basically, is it based on longitude and latitude? And how are you translating that on a picture?
I mean, are you asking how I'm plotting the lines?
Yeah, for the pins, like you're putting on the map, are they the
Okay.
values of the position, if they're based on longitude and latitude?
It is latitude and longitude. Yeah, you're
How
right.
are you translating them there?
Okay, so I use this. I use this topo JSON, I guess, if I remember correctly. That let me check. That's the correct one.
Wouldn't that be a simple problem? Just because longitude, latitude coordinates are linear in some sense. So all you got to do is, right, if you want to translate 30 pixels to your right, there's a scaling number that you can use to.
Mm-hmm. So
to do
no, I think
I mean, actually,
didn't
that's
see
a
any.
separate topic, but yeah, it just popped up in my head.
So I didn't see, I mean, any issue by using topo JSON, because we hold the city's database. I mean, that is also available actually. So it will have the latitude and longitude of all the cities, and the topo JSON was converting, that into plain X and Y points, with the latitudes to X and Y points. Wherever you want to play. So I didn't face any issues, but I mean, mine was a simple requirement again. So, it was, if it is even close to the exact point, I mean, I was okay. We were okay with it. So, again, this will create issues if you're having, more zoom or, more detailed map. Then it needs to be accurate. I would suggest using an API for that, maybe. That will make more sense there. It's a simple, if it is a simple requirement, then it makes sense. Otherwise, it won't.
Got it.
If accuracy is more important. Yeah.
Do you want to tell us a little bit about like use cases involving the need for this implementation, or when you found this helpful?
Mm-hmm. So basically, I mean, I explained on clustering when you want to use clustering, but implementing clustering is totally dependent on how much heavy I mean your map will be. So ours like we during development we didn't face any issues, but when the customers started using it, we didn't realize they were adding so many deployments, and we were not aware of it. I mean, we didn't test those scenarios. That was a thing that we missed. And when we got customer issues, we saw them using lots and lots of markers overlapping each other. So we were not even able to read. So let me I mean, I think it will work. Let's try. I saw one, I mean, like I said, there was one issue with overlapping happening still, because the cities were falling outside each other. So let's try that. Let's change Detroit to, let's try Montreal.
Our neighbors to the east.
So this was the issue I was talking about. So if you see here, these two are again close to each other, like Detroit and Toronto, but still they fall under different grids. So this was happening across, and not only for two specific location or such, but it was happening across, and it looked really, really bad. So again, clustering, if you are implementing your own maps, I mean, with a lot of markers, clustering is very much necessary. I mean, if you are using any other library, then it's fine. They already provide the API. You can directly use it. But if not, again, clustering will be really useful in that scenario. This is what we faced basically.
So then working with like large volumes of data that requires a kind of a sorting or visualizing and different kind of like unreliable, like maybe like zoom levels, indeterminate kind of adding of markers.
Yep. And it again, like I said, it helps in performance improvement as well. See, because when you have, two separate nodes, this is a separate icon and this is taking a separate node and all that. When you're grouped together, you're going to have only one marker. So that will, benefit performance wise as well. So again, you can go ahead and look for all the libraries that have, better implementation, obviously, because a lot of, developers are working on it, they're maintaining it again. But if you want to know the concept and understand how it works and all that, you want to do more customization, you can try your own way of implementation.
Yeah, it's really awesome knowing how it works, because I know this because I didn't know the theory, but I implemented it at a company. Because I didn't know like a lot
I want
about
to hear about this journey as well.
a lot about
this
data
might
structure.
take up some time. I want to let Guna like finish his presentation. If he has any other notes, I have to say that everyone has really contributed and also like asked a lot of like awesome questions in this discussion, because this is a topic that you only begin to touch on when you have to work with maps and geospatial data. And if someone hasn't, like a tech lead at your company hasn't determined how you're going to do that. So yeah, the questions aren't to, try and slip you up or whatever. People are genuinely curious. And we really don't have a kind of talk like this usually where people are asking, like really like wondering how this works. So thank you so much for sharing this with us.
It was real fun.
I think there will be many
questions. For another question. I got a question.
Yeah. Go on, Brian.
So first off, thanks for showing this off. This is a JS talk, so obviously you want to do this in JavaScript to talk. But when you're trying to think about doing this, do you have access? Do you work with your database that retrieves the point data at all? And if you do, did you ever consider before you went with the front-facing route? Did you consider that letting the databases do the R-tree work before coming out of the database itself?
No, we didn't even consider it because our requirement was, minor and the UI should be okay with it. That's why we didn't. I mean, it won't scale as well. So we didn't consider putting it on the back end.
Okay, thank you.
One of the popular contentions or something I realize that I can do coming from a very front end oriented background is that all the things that I do in like Redux or like all the things that I do as computed type of functions could be done server side, but when and how? And these concerns started to surface as I got to know the way to manage state in frameworks and how other people did things, especially on back-end oriented products. But yeah, if you talk to me about maps, I only know that one thing, and it's through D3 and React. And so this was absolutely illuminating. Are there any other questions? I see that Ari is giving a comment as well, and I really want to let him like also give a little like note about what JFrog does, not to, you know, like eclipse anything that like Guna has said. Do you have like any other final comments in your talk before we wrap up? Because I do notice that we are coming up to the hour, and we have 15 minutes left in this meetup. I will
just wanted to
allow
say,
for us to have a very pregnant silence. Sorry, go ahead, Guna.
just wanted to say thank you for having me here, and yeah, please let me know if you have any concerns. I'm not an expert on this. Even I learned and tried this, and yeah, I mean, and this concept, I mean, is clustering, but Quadtree is not the only way of implementing it. There might be some other better ways as well that I wouldn't have come across. Maybe if we can find, we can even discuss it. I'll be part of the Slack channel. Maybe I'll also, you know, find time if we can find out a better way. We can go through it. We can find it. But I mean, yeah, clustering is the concept, but Quadtree is not the limit, is what I feel. So there might be more, you know, algorithms that might come up, and you know, that might have a, you know, API like how D3 has for Quadtree. So